talked about transformations. And we talked about three types of transformations that are congruent. We talked about translations. That's a slide, okay? Translations or slides. We talked about rotations or turns, and we talked about reflections, which we call flips, and they're all congruent transformations. So today we're gonna specifically talk about translations. Now, this word and this word, transformation, they get confusing. Transformation, that's everything. That's translation, rotation, reflection, dilation. That's all of them, okay? Translation is just a slide, okay? That's where we just take a point, we slide it over to a new point like this and say, okay, there it is. And this line isn't here. I shouldn't draw that. Here. A lot of times we draw that. I just kind of move it over, right? There's A prime. The thing is, it's really hard to say how to do it. How can I explain to somebody how to move point A from here to here? Okay, there's some type of up component, and there's some type of over component. You guys all agree with that? Okay, there's got to be a certain amount of up and a certain amount of over. Now, you guys don't really know about vectors yet. We're going to talk about vectors later, but you know, a vector can have a direction and a magnitude. So we can say, okay, move this direction this far. But that's hard. That's hard for us to do, to point a specific direction and then move a specific distance in that direction. That's kind of a difficult thing to do. But going straight up and straight over to get there, we're actually pretty good at that. And where do we see that a lot, guys? Yeah, coordinate plane. And do we talk about up and over, or do we do the over part first? Yeah, don't we do the x coordinate thing first and then the y coordinate thing second, right? So with slope, it gets a little confusing because slope is the change in y over the change in x, and we're always going so much up and then so much over. But when we're locating a point on the coordinate plane, we always go to the x coordinate part first and then the y coordinate, don't we? Okay, that was the question. So at the end of that, you guys are all supposed to nod. You all agree? Okay. All right. At least nod for me. All right. So a lot of what we're going to be doing is going to be in a coordinate plane to make translations easier. All right. So we're just going to have a point. I'll call it point P. And then we're going to slide this sucker some amount, maybe over to here. P prime. Now, why am I calling this one P prime? Yeah. So I have what I call a pre-image. Okay, and then I have an image. The pre-image, that's where you start, right? And then the image, that's where he ended up. When we took the picture of Creek yesterday, Creek himself is the pre-image, and the thing on my phone, right, that was the image. Does that make sense? Okay. So that's the way this works. And we just have to have some type of rule. Like, how do we go from here to there? And it's really difficult to say, okay, point this direction and then go that far. And that distance might even be a, weird distance, like radical 53 or something. right? That's kind of a difficult thing to do because that's an irrational number. Going that distance can be kind of difficult. But, you know, I'm going to write this for you. I'm just going to write a rule and see if this makes sense to you. What do you think? What do you think that means?
The point of x and the transpose of y and
So my horizontal component, my x component, is 10, positive direction, and my vertical component is 7 in the negative direction. That's easy, isn't it? That's easy to do. So take a look at the book, page 174. You guys all there? And we can all look at the same thing. So if you just look at the bottom of page 174, core concept, we have a translation moves every point of a figure the same distance in the same direction. More specifically, a translation maps or moves the point P and Q of a plane figure along a vector to the points P prime and Q prime, so that one of the following statements is true. And then it has this P prime equals Q prime. What the heck does that mean? P prime. That is a segment. Can everybody find that segment? Okay. And then find Q prime. Can you find that segment? Are they marked congruent in the picture? Are they parallel to each other? Yeah. So if we move P and Q the exact same direction and the same distance, we end up with P prime and Q prime, and if we connect those two, we get a segment that's exactly the same length. And is it rotated or flipped or anything like that? No. If you put your finger on PQ, everybody put your finger on PQ, I just pretend you just slide it over, right? That's all you're doing. Your hand isn't rotating, you're not flipping it or anything like that, are you? You're just putting your finger on there and sliding it over. Okay? So now let's look over. Now, one thing I want to point out. In this book, the pre-image is always blue, and then the image is always red. But that's not like some kind of rule or anything. That's just the way they do it in this book. So if we look at example 2 now, we have a triangle. Everybody see the blue triangle? ABC, right? You see the red triangle? What's it called? A prime, B prime, very good. A prime, B prime, C prime. So, how do we translate that blue triangle over to where the red triangle is? Well, we don't move the whole triangle at once, do we? No. We just translate each individual point. So we take point A, and what do we do with it? Over 5, down 1? Is it up 1 or down 1? Down 1. Now I want you guys to notice there's this little thing there. So we have point A, which is right here, okay? And they go over 5 and down 1. So we end up with, you know, I can even do this in color for you. Here. So we got point A right there. And then they went over 5 and down 1. So we got A prime right here. So this is our translation. We just kind of moved it right along there. And I want you to look at this thing. It kind of looks like an ordered pair, but it has like a less than greater sign around it. Like a less than sign and then a greater than sign. See that thing? Okay. that's the vector. So that's telling us what to do. Now it's not telling us point this direction and go this far. What is it telling us? To the right 5, down 1, right? That's pretty simple, isn't it? So this is what we call vector notation. It just tells us what to do. That's it. So now when we do point B, where's point B? At 2, 4? 2, 4, is that it? Okay, so if we just go over 5, 1, 2, 3, 4, 5, down 1. Okay, so there's B prime. And then point C is right here, and we go over 1, 2, 3, 4, 5, and down 1, and there's C prime. So we have it like that. And we end up with this figure that's here. And I want you to notice that all of these parallel lines why do you think it's important that all those lines are parallel? We just learned in the last chapter when we have parallel lines and a transversal, do we have some angles that are congruent? Right? Well, if you look at this, I mean, think about what's going on with these angles and stuff as they hit these parallel lines. See, we kind of have these transversals coming along. We have our two parallel lines. See how the angle measures in the triangle here are conserved, and they're the same in the triangle when we get over here? Okay. Now I'm making this all kind of complicated in actual fact. I mean, it's easy. I give you a point. We give you a vector. -3, -8. Can you do it? Ooh, -8. There we go. Can we do this? Sure. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. There's P prime. Done. That's how we move a point. How do we move a segment? So here's PQ. How do I move that whole set? How do I translate the whole segment? Yeah, just do the same thing with each point. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. There it is. There's Q. There's our segment. Notice it's not rotated. It's not flipped. Right? It just slid over. What if it's a whole triangle? Same thing. We just take it. We move it back 3. 1, 2, 3. Down 1, 2, 3, 4, 5, 6, 7, 8. Right there. We'll call this one R. This is R prime. So if we had a triangle, we could move it that way. Well, what if it has more points than just a triangle? Yeah, we just move them all. You just move every single point that way, and you've got it. Okay? So, there's a couple of ways you're going to be told how to move things. One of them is called vector notation. And it looks like this. Everybody get it? To the left 3, down 8. Okay. The other one is called coordinate notation. And this is just a different way of telling you how to do it. In fact, I should say it this way. It's a little more clear about what's going on. And when you read it, you say XY is mapped onto, everybody say that, is mapped onto. XY is mapped onto, try it again. Oh, good. X subtract 3, Y subtract 8. This is a little more of a thing to write, but it's pretty dang clear about what to do, isn't it? Okay, so you've got to be able to recognize both vector notation and know it's called vector notation, and coordinate notation and know it's called coordinate notation, and be able to read it correctly. X, Y is mapped onto x subtract 3, y subtract 8. Okay, so let's turn to page 176. Let's take a look at that. Yesterday I called translation, I called them congruent transformations. Congruent transformations. Now they're not always called congruent transformations. You need to know both these names. The other one sometimes we call it a rigid transformation or a rigid motion. And you might see it worded this way on the end of your test, or like an ACT test, the ACT prep. They might call it a rigid transformation or a rigid motion. And that just means that the pre-image and the image are congruent. They're the exact same size and shape. So as we look down at the bottom of page 76, see the blue line on example 5? See the red line? Are they exactly the same length? Okay, those two segments are congruent, aren't they? Okay, because their measures are equal. So that's what we call a rigid motion or a congruent transformation. Now the next word we need to talk about is called a composition of transformations, which just means we're going to do more than one thing. Okay, we're going to do two things. So if you look down at example 5 now, we're going to look at that one rather than have me draw it. We're going to take the blue line segment. See the blue line segment? It's called, isn't it RS? Got to go to the glasses. And what are we going to do with it first? Yep. Slide it where? Yeah, where does it end up? Everyone see the red segment? Yeah. And you see the arrow going to the red segment. And then after that, it gets moved again. Yeah, back over. So this is kind of an odd thing, but the first mapping function looks like this. XY is mapped onto x plus 5 and y subtract 2. So from the blue into to the red one, we go to the right 5 down 2. Everyone okay with that? Okay. Now from the red one to the green one, XY is mapped onto x subtract 4, y subtract 2. So to go from the red one to the green one, we go to the left 4, down 2. Right? Is there a way we can go directly from the blue one to the green one?
Yeah.
Everyone look at the picture for a second. Kind of think about a rule that you would come up with to go from the blue one to the green one. You got it? So you got your rule? Okay, now look up here at me for a minute. See how I added those two things together? Is that how you get from the blue one to the green one without having to go to the red one first? Pretty simple, isn't it? Okay, and you don't have to look at the graph. You don't have to count it out. And that could be really nice if these points were further apart. Maybe they didn't fit on a 10 by 10 graph or something like that, right? If this was like real life and we were looking at a map and we were trying to go from one location on the map to another location to another location, and hey, I don't have to walk, I'm flying in an airplane or something like that, and we can go directly from here to here. How do we do that? And so we can add these together. And of course we can add them together if they're vectors too, can't we? If it just said 5, -2 for one vector and -4, -2 for the other vector, we can add those two vectors together. Same thing, same result. So what's this notation called?
Vector.
And this one's called coordinate notation. Okay. You guys all realize this is like crazy easy, right? Okay, it is super, super easy. Take a point, left, right, up, down, new point, no problem. Okay, a lot of it's just kind of the words and things like that that we have to learn to be official. Okay, so we're doing chapter 4.1. I have some graph paper up here. I'm sure you're going to need it today. I made a whole bunch so you can use it. And there you go.